Greetings. For this assignment, I chose to make a video for topic 6.3a. And to solve the first question, it says to find the limit of s of n as n approaches infinity. And also I need to try it without performing any simplification. I think simplification in this case means to just don't expand the whole function. So I need to find this one, but because n is approaching infinity, I only have to look at the terms with the greatest exponent, so which is n to the power of 4 in this case for numerator and denominator. Because any other terms that has exponents lower than 4, we can ignore them because they are smaller than n to the power of 4. So we can basically think this as this, and the other terms could be ignored because we only look at the coefficients of the greatest term here, which is 81/4. For the second question, we do the same thing. So it is the greatest term for the numerator and denominator in this case is n to the power of 3. Also, with the highest degree is n to the power of 3 or n cubed. So we can think of it as this and ignore the other terms, which gives 64 times 2 over 6, which is 64/3. And I also apologize for my bad handwriting because I'm not quite used to writing without my pencil. And for number 3, like number 1 and 2, we look at n squared because it's a term with the highest degree in denominator and numerator. So this one, the limit of s of n as n approaches infinity is equal to the limit of 18n squared plus something over 2n squared as n approaches infinity. We only look at the coefficients, so it's 18/2, which is 9. And for number 4, we do the same thing. So we look at n squared because n squared is the term with the highest degree in denominator and numerator. So the limit of s of n as n approaches infinity is equal to the limit of n squared plus something over 2n squared. And because we only look at the coefficient here, so it is 1/2. For next part, it says to find the area for the sum of n terms, and I need to use the formula to find the limit as n approaches infinity. So I think the problem basically means to evaluate the given expression. For number 5, when I simplify it, I can write it as this. Just multiply these two terms. So I get this expression. And I know that because even though in this case n is approaching infinity, if you only look at this term right there, n is actually a fixed number. It's a constant in this case because n is the n value. So we can take out the n squared out from the sum notation. So also 4, because 4 is also constant. So we can rewrite like this. And using the formula, we can know that this is equal to times 2 over n plus n times n plus n times n plus 1 over 2. So in this case, it's like number 1 through 4. We only look at n squared because n is approaching infinity. We only look at the coefficients of n squared. So this is the coefficient of n squared in the numerator is 4 and in the denominator is 2. So that's why the final answer is 2. For number 6, we do the similar thing, but I think because we have cube right here, the expression will be quite dirty. I think I can expand this term. So I get, because a plus b cubed is equal to a plus b cubed is equal to a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So using that, I can write it as 1 cubed plus 3 times 1 cubed times 2i over n, so 6i over n, plus 3 times 1 times the square of 2i over n, so that is 12i squared over n squared, plus this thing cubed, so 8i cubed over n cubed, times we can write it like this. And using the common denominator for the case here is n cubed, so we can write it like this: 8i cubed plus times n, so 12i squared n plus n squared, so 6i n squared plus n cubed, times times 2 over n, 2 over n. And similarly, this case we can take out these. Maybe I think I need to use different color. We can take out these because they're actually constant here, even though n is approaching infinity. If you only look at this term, n is constant. So when I take it out, we get 2 over n to the power of 4, and the rest, but also this case we know that, no, I think I will just write it: I squared n plus 6i n squared plus n cubed. So we need to find this. Because I think I will be running out of space, I will simplify this one to here. So because I think I will be running out of space. So actually this one can be rewritten as we can separate this using the properties of sigma. So we can write it like this: I equals 1 I squared plus 6n squared equals 1 n to I plus plus n to the power of 4 because this one is equal to n to the power of 4. I just simplified it, and using formulas we can rewrite this as the formula for this one is 4, I believe it is this one, plus 12n times 6. We can write it like this, plus 6n squared times n plus 1 plus n to the power of 4. So if we simplify this, we get 2n squared and n plus 1 squared plus 2n squared times n plus 1 2n plus 1 plus 3n cubed plus n to the power of 4. But similarly, in this case, we don't have to expand everything because the term with the greatest degree, the numerator is n to the power of 4. So we only have to look at n to the power of 4 because it is also the term with the greatest degree in the numerator too. So we get 2 times it is 2 here, so 2 plus this one is 2 times 2, so 4 plus 3 plus 1 over 1, which gives us 7, 10, 20. Yes, so 20 is the answer for number 6. For next question, it is use the limit process to find the area. Find the area of the region between the graph of the function and the x-axis over the given interval. So we cannot use. We need to use the limit notation for this problem. In the previous lessons, I learned that the area of the region between the graph of a function and the x-axis over the interval a comma b, it is equal to the limit of this as n approaches infinity. I will just use k this time. F is a function for this case, so and n is the number. And this is using the right side endpoint, and the reason for this case is because this is the length so this is the length and this is the height. So we are adding the the Riemann sums. This is a Riemann sum. So if we apply this here, we can just substitute. So we get this 4 minus 1 and 1 plus 4 minus 1 over nk. And I will just take this one out because we can do that according to the properties of sigma. And let's substitute this value to the function. So we get 4 times 1 plus n over 3 over nk minus 2. So if we equal signs. If we simplify this, we can get this It's 12k over n plus 4 minus 2, so plus 2. And using the properties, we can reevaluate this one. So it is times 12 over n, or we can take this one out, and this one right here is equal to 2 over n times n plus 1. So I will multiply this one right here, and then for any constant, let's say constant c, it is equal to c times n, so I can write it as 2n. Is it? Yes, we can write it like this. And because I'm running out of space, I will use my right side. So this one is equal to we can simplify this a little bit, plus 1, but I want to use common denominator, so we can do this. And this is just like number 1 through 4. We only look at the coefficients of the terms with greatest degree on denominator and numerator. So it is 3 plus 2 over 1, which is equal to 5, but this is wrong. Oh, my mistake. I forgot 6 here. 3. So this. So 18 plus 6 over 1, which is equal to 24. See, so the answer is 24. And this is for number 8. For number 8, we can use the equation above that, and it's b minus a, so 4 minus 2 times a plus b minus a over n times k. And when we simplify this, we can get I'll just take this one out because we can do that according to the properties of sigma. And we can plug in this one right here, so it is 2 plus n over 2k. I am skipping few steps, but it's not like a huge step, so we can do this. And let's simplify it. We can make it like this, 4k squared. Am I doing it right? Yes. Plus n over 8k plus 4 plus 2 plus 2k over n. We can add the like terms, so we get this. So 4k squared over n squared plus 10k over n plus 6. I'll continue the rest here. And like the other questions, I will simplify. Like the other questions, I will try to simplify this one with easier method. So we can do it like this. I will just use this one. Times. It is 4 over n squared times n plus 1. 2n plus 1 over 6 plus 10 over n times it is n times n plus 1 over 2 plus 6n. And when we further simplify this, we get, well, we get this. But I would like to make a common denominator, so I will just write it. I will just use 6n squared. So it is 4 times, n, 4n times n plus 1, 2n plus 1. And because it's 6n squared, I need to times 3n, so plus 30 n squared n plus 1 plus it's just n. No, it's 36n cubed. Yes. Oh, oops. I need to use this one. Oh, I made a mistake here. I did not properly close the parentheses or brackets. So in this case, we also only look at the coefficients of n cubed. So it is 6, something over 6, and the something is 8 times 2. So 2 times 8 plus 30 plus 30. 36? 36 should not be here. Oh no, never mind. 36 is right. So we get quite a huge value. It's 4474 over 3. It should be right. Yes, it is right. It's 74 over 3. For number 9, we can do the same thing. So is the limit of this is k equals 1 to n, b minus a, so it's 2 minus 1 over, I'll just write it, 2 minus 1 over n times f, 1 plus 2 minus 1 over n times k. So this is the area, but we need to simplify it. Oh, the expression is very long here, so we can, I will just take this one out here. So we don't have to do it, but it just psychologically feel better for me. So it's n over k plus 1. Oh no, f here. And it is, if I plug in the value to the function here, I get 2 times n plus k over n squared minus 3 k over n plus 1. Oh, plus 1. So we can further simplify this. That should be right. So it is 2k squared over n squared plus 4k over n plus 2 minus 3k over n plus 3. No, minus 3. Minus 3 plus 1. So we can erase this. And we can also erase this. So let's make common no, we need to do more. So we can write it like this. It is times 2 over n squared times n plus 1 times 2n plus 1 over 6 plus it's just k over n, right? So times n plus 1 over 2. Yes, this one is n. In this case, let's make common denominator. So I will just go with 6n squared again, and it's 2 times n plus 1 times 2n plus 1, is 6n squared, so I need to times 3n, so plus 3n squared and plus 1. We only look at n, the coefficient of n cubed, so this is equal to something over 6, and that something is 4 plus 3, which is equal to 7 over 6, which is the right answer. Yes. For number 10. For number 10, it says between the x-intercepts. So x-intercept is very easy. We can just write this. So x equals plus or minus 3. So it's just in these intervals. And let's do the same thing. I will just start my solution from here. So I get n b minus a, so it's 3 minus negative 3 times, whoops, I forgot sigma, the most important thing, the Riemann sum, and it's k equals 1 to n, and it was 3 minus 3, negative 3, times f negative 3 plus 3 minus negative 3 over n times k. So we need to simplify this. We get I forgot. We get I will just take this one out, so it's 6 over n, and this time it's quite nice. It's relatively clean. So 6k over n minus is n minus 3 squared, which gives us it's k equals 1. The 9 cancels out, so it's 36k squared over n squared. Minus 2 36k over n. We can further simplify like this. K equals 1. Oops, no, I will just write it like this. Times 6, n plus, n plus 1 minus 36 over n times n plus 1 over 2. So this case we also only look at the coefficient of n cubed, because that's the highest in the numerator and denominator. So denominator we get let's make 6n cubed as our common denominator. So it's 6n cubed. For the top part, it is 6 times 36 times 2 minus because we times 3n squared. 3n squared? No, we times 3n on both sides to make 6n cubed. It is 36 times 3, which is equal to 36 times 9 over 6, which is, I believe, 40. No, this is wrong. Where did I make the mistake? Sorry, I forgot times 6 from here. So we get negative area. Area cannot be negative. Area cannot be negative. There is something wrong here. Oh no. I accidentally swapped. Yes. Sorry. So it is plus. So this should be minus. This should be plus. So it is. It is 3 times 18 minus 12 equals 6. So answer should be 36. And that is correct answer. And for today's last question, the last problem is this one. Oh, this is very clean problem. I love it. So, it is. This is the area to n. This is k. So it's 4 minus 0. Oh, it's 4 minus 0 over n. So which is 4 over n times a plus 0 plus. So I would not write it. This times k. So this is very clean problem. And we can plug this in. So n cubed 64k cubed, and further write it as this. Oopsie, 64 times 4 k cubed, so which is equal to infinity times 64 times 4 over n 4 times 6 n plus no, this is not right. N squared n plus 1 squared over 2. I think this is, no, this should be right. Yes, the formula is correct. And the highest degree is 4 here, so we only look at n to the power of 4, so we can rewrite this as 64 times 4 over 2. I mean, everything is right until now. Oh no, it's 4 here. It's 4 here. So the answer is 64. This was the solution from number 1 through 11. Thank you.